Those of you just joining us, this is the Southeastern Regional Climate Hub workshop, day 2. We're going to be starting off with Dr. Mark Risse. He is the Director of Marine Extension and Georgia Sea Grant and Georgia Power Professor of Water Policy at the University of Georgia. He has led national extension efforts with Livestock and Poultry Environmental Learning Center to equip livestock and poultry producers with climate adaptation and mitigation efforts. He has received recognition as a fellow in the International Soil and Water Conservation Society and is a Walter Bernard Hill Fellow. That's the university's highest honor for public service and outreach. He's also a PI in the Climate Learning Network, which is helping to host this workshop this week. He's going to talk to us about mitigation in livestock and poultry systems. And with that, I'm going to hand it over to you, Mark. Do you have control of the screen?
Yes, I do.
Great.
And good morning, everybody. In Dan's introduction, it's stated that I'm Director of Marine Extension and Georgia Sea Grant here at the University of Georgia. But when I started this project, I was with Cooperative Extension and have a background in biological and agricultural engineering. And that's when I got involved in a lot of this type effort. This morning, I'm real quickly going to cover. I was asked to cover mitigation strategies for livestock and poultry producers, but I'm actually going to talk about adaptation and mitigation strategies. Many of the things we do to mitigate the impacts of livestock and poultry production also help us adapt. So I have trouble separating the two at times. A lot of what I'm going to talk about is not my work, but the work of our regional team that's been focused on this for the last 4 or 5 years. And Dan introduced this yesterday on E-Extension, our Livestock and Poultry Environmental Learning Center. And then you can go look at our climate change page there and get more details. I do want to again plug the course. I think that was mentioned by Pam and by Dan, and it is online. It is a great resource out there for those that want more in-depth information on just climate change in general, and then especially related to animal agriculture. It's gotten very good reviews, and it's probably our best output from the project. Right at the beginning here, I've got a couple slides that I think Pam had talked about a little bit yesterday, and some of them look very similar, but I would really want to focus on the impacts of climate change on animals and on animal agriculture in general, and talk about some of these before I go into mitigation. I guess one of the biggest things we're most concerned about on livestock and poultry farms is animal comfort and the impacts that increased temperature are going to have on these operations. Heat stress is critical in a lot of animals related to reproduction. Dairy is probably the most sensitive, but you know, we've heard about death loss on cattle feedlots for beef cattle and poultry houses on swine farms. You know, temperatures are critical, and we've got lots of adaptation strategies with cooling systems, and you know, we've been working for years to make animals more comfortable so that they perform better. But this is going to be a harder and harder job with increasing temperatures. And some of the literature says that you know, the most critical thing is the warmer nighttime temperatures that most animals can withstand some temperature stress, but the body needs a period of recovery, and that's one of the things that in the southeast we've heard more from producers is, you know, the temperatures may not be increasing. That the high temperatures, you know, don't seem to be increasing, but it just doesn't cool down as much at night, and that can really impact productivity on a lot of these animal operations. increased temperatures also impact feed on these farms. Some of the impacts could be positive. We're going to see longer growing seasons for crops, but that also means longer growing seasons for weeds and pests and increased weed and insect pressure. In general, we think there'll be less predictability in feed supplies, and that'll be due to not just temperature, but also drought or extremely wet conditions. One of the big concerns that some people have out there is the impacts temperature could have on corn production, and it could actually get too hot to produce corn in many parts of the U.S. where we're currently producing a lot of corn, and that may lead to a change to more pasture-based systems, because we think that the impacts on grass should be positive. We should see increased grass growth and a longer growing season for pastures. But there, once again, it's going to be important that we get the rain that we need. Precipitation changes, Pam talked about this. They're not well determined. However, we do expect that we're going to have more intense storms with longer dry spells between them. On animal operations, a lot of this is going to impact the animal feed more than the animal themselves. A lot of the animals are produced indoors nowadays. Those that are out in pasture-based systems, could probably weather these changes, but this is going to have big impact on soil erosion, stress on plants that are growing out there, and the ability to irrigate. And perhaps more importantly are seasonal changes in the precipitation. And again, Pam showed this yesterday, but I can tell you that these type changes can have profound impacts on animal feeding operations and beef operations. In particular, some of the experiences, I have a small beef cattle operation, and some of the things I've been dealing with over the years is we used to be able to grow fescue really well in this area of Georgia, and for years I've been trying. I had redone a field, and I was trying to reestablish fescue, and just having difficulty doing it and getting a good fescue stand out there. Well, USDA redid their plant suitability maps, and I noticed that the line, the growing region that I'm in, that fescue is well suited for, moved from being 30 miles south of my farm to being about 30 miles north of my farm. And fescue's just not doing as well in this area of Georgia, and traditionally it had, and that's could be due to the temperatures. Also, we're seeing big increases in the amount of overseeding that's done, and a lot of that I think is driven by these changes in seasonal precipitation. If summer and spring is going to be more droughty, and you're going to have less dependable forage supply, and it seems like we're getting more rain in the fall, it makes overseeding these pastures more important, and maybe getting an early season spring hay crop off of them. And we're seeing livestock and poultry producers respond to that, I think. Other changes on water resources, one of the things that I think we often overlook is higher temperatures increase water use, simply because you're getting more evaporation, you're getting more energy use, and so water is being used a lot more. So even if rainfall stayed exactly the same and we just have increased temperatures, we're going to see more stress on water resources and our ability to irrigate. Unknown effects on groundwater, but it could draw down supplies, especially if we're competing with other sectors. More erosion and nutrient loss due to the higher intensity rainfall, and more and longer droughts. And then I think Pam may have had this slide exactly in her presentation. The extreme weather also increases risk on these animal and feeding operations and poultry farms. You know, those farms more than any other probably have very large investments in facilities, in infrastructure. You know, it's not just a field in most cases, but you've got the buildings associated, the feed storage, if you're a dairy farm, you've got, you know, a milking parlor and everything. And extreme weather can really impact those. So it's more risk for these operations, and risk management will become more and more important, be it for floods, wildfires, tropical storms, snow, ice, you know, these extreme conditions. Livestock and poultry farms really have to be prepared for those. So moving more toward mitigation now, you know, I think greenhouse gases are here to stay. Our group really struggled with this Livestock's long shadow report that came out, and it was done by the UN and said that you know, meat production contributes more greenhouse gases than the transportation sector, which we really had problems with in looking at it. Homner et al. Did a study. He's out at UC Cal Davis. And in the United States, at least, you know, transportation accounts for about 26% of our emissions, while livestock production is less than 3%. Globally, you know, we've got very efficient livestock and poultry production in the United States. Some areas where it's less efficient, and they have much smaller transportation sectors, you know, it might be true that that animal production could have a larger impact in certain companies. Globally, we really don't think that's the case, though. That his papers point out several flaws in the study and the way the accounting was done, and he actually suggests that the global impact's about half what transportation is. More importantly, I don't think any of these reports are going to drive it. I think what's going to drive greenhouse gas reductions in animal agriculture is the markets. And, you know, I can say here in Georgia, poultry is our biggest animal industry, and I don't think 10 years ago they were that concerned whatsoever about greenhouse gases, about carbon footprints, and I can tell you now they are, and they are because the foreign markets, because Walmart, because many of the U.S. major food industries all have taken pledges to reduce their carbon footprint and are demanding that people that sell to them and work with them take their carbon footprint seriously and work to reduce their greenhouse gas emissions. And you know, I think that's going to drive this in the future as much or more than even government policies. When we look at U.S. greenhouse gas sources, and this is for all of agriculture using EPA data, you know, ag is about 6.5% of the total emissions. And most of that comes from soil management in agriculture. But the number 2 and number 3 sources are enteric fermentation, which happens in most of our ruminant animals, and manure management. So managing animal agriculture, we can substantially impact agriculture's emissions. Now, before I start talking, I'm going to start talking about carbon footprints, and generally this is how we measure the greenhouse gas production or impacts. It's the total greenhouse gas emissions for a given person, place, event, or product. And a lot of times we measure carbon footprints using a tool called life cycle analysis. where we measure all the inputs and the outputs and impacts of a product and do resource accounting. And life cycle analysis should help you avoid shifting environmental impacts from one area to the other. If you look at the entire life of a product, then it's much more meaningful than just looking at the emissions that are simply created at a certain point. Boundaries are really important when you look at a carbon footprint on a operation, and you can have one let's take a sample product such as a pound of steak. I could have one carbon footprint if I look at that pound of steak all the way from producing the crops and the animals to going through a sale barn, having a processor buy that, processing that meat, having a consumer or having it sit in a grocery store for a week, and then move to a consumer where it's sitting in a refrigerator and then ultimately being cooked in some manner, and then the packaging disposed of. And so I could have a carbon footprint that goes cradle to grave, and that would be all the way till the consumer eats that that steak and disposes of the packaging, or cradle to farm gate, which is just till the farmer sells that pound of steak. And oftentimes those would be different carbon footprints, and oftentimes it makes sense to go cradle to farm gate because it's beyond that farmer's control in how that product is going to be stored and cooked and marketed and all of that. So if we're simply trying to compare two different farming practices, well, then we probably want to go cradle to farm gate. If we're trying to look across an industry and where are opportunities for reducing carbon footprints, then maybe cradle to grave might make more sense. But whenever you're working with carbon footprints, it's really important to look at what those boundaries are, because you can have totally different answers depending on those boundaries. And here's an example. This is a generic dairy carbon footprint, and this one was cradled to grave, or going all the way through to the consumer. And you can see where the various methane, nitrous oxide, and carbon dioxide emissions came from. And most of it is enteric fermentation, the animals themselves breathing. But you can see consumer consumption and disposal has an impact, the retail, the transport, the processing. That's all important. And if I'm not looking at that, my carbon footprint might be 25% less than a measure that it is going just to the farm gate. Farm energy is another thing that, sometimes we see that included in carbon footprints, other times we don't. And I guess you can assume whatever you like, but it's important for people to know what the assumptions are. Units are important as well. Here, these two graphics are comparing the carbon footprint of producing milk, and one's the carbon emissions per cow. And if you look at that, you can see, today's cows produce a lot more greenhouse gases than the cows did in the 1940s. But they're also producing a whole lot more milk, and if we look at the carbon footprint or CO2 equivalents per gallon of milk produced, you can see that today's cows are a whole lot more efficient than they were in 1944. So we think that looking at it, per gallon of really energy-corrected milk, which accounts for the fat content of the milk, is probably the most representative way to look at it. But different people look at it in different different ways depending on what they want to show. I'm real quickly going to get into one study we just recently completed. I had a graduate student, Lynn Ma, that helped me with this, where at the University of Georgia, our campus has taken a carbon pledge, and we're going to reduce the carbon footprint of the University of Georgia by 20% by the year 2020, and they wanted to include farms in that. So real quickly to do they were using a tool called Campus Carbon Footprint to do this, and really that model just had in it how many animals do you have and how much fertilizer do you use, and it came up with an estimate for the carbon footprint of the various farms, and that was the baseline that we're using for all of the University of Georgia farms. Well, we didn't think that was a very good way to do it, because basically the only options we had for reducing the carbon footprint of our farms are not using fertilizer or getting rid of animals. And that's really the only, using that method of calculating your carbon footprint, those were the only two ways we could reduce the carbon footprint of UGA farms. So we wanted to look at other options for calculating the carbon footprint and really make recommendations for management to reduce the greenhouse gas emissions. Now, we looked at just two UGA farms in this. One is the Double Bridges Swine Center, a relatively new farrow to finish swine farm, and the UGA Teaching Dairy. This has about 150 milking cows on it, produces all its own feed. We selected these two farms because, well, because the project I'm involved with was focused on animals, but these two farms were also the largest emitting farms that we had at the University of Georgia. We did all Tier 2 cradle to farm gate life cycle analysis, so we were just looking at producing the pork at the farm gate or the milk at the farm gate, and we used 5 different tools that we could find out there in the literature. The Clean Air Cool Planet Campus Carbon Calculator, that was the tool that UGA was currently using. We used Farm Smart, which was developed for dairy farms and is supported by USDA. A tool called the Cool Farm Tool, which is, I think, out of the United Kingdom or England. A process-based tool designed for general agricultural operations. The Comet Farm Tool, and this is the one promoted by NRCS as a tool for U.S. farmers. One of the things that was relatively unique about this tool is it was the only one that didn't really include energy use on the farm, and all the other tools did. And then the pork producers have worked on a pig production environmental footprint calculator, and we used that on the swine farm. And part of this project, we're also looking at these different tools, trying to figure out, if I was a producer and I'm concerned about my carbon footprint, which of these tools should I be looking at using? So here are some of the results, and there's a whole thesis on this, so I'm not going to go into that much detail. But at the swine farm, I was somewhat surprised that the numbers I felt were fairly close. The Clean Air Cool Planet, was saying around 678,000 CO2 equivalents per year, and that was very close to what Comet was predicting. But then the other two were almost half of that, the Cool Farm Tool and the Pig Production Environmental Calculator, the National Pork Producers Tools. We don't really know which one is right because we don't have the budget or the ability to actually go out to the farm and measure all these emissions and to know how much emissions are embedded in all the feed we're buying. So it's hard to say which one is right, but I can tell you for this one, the Clean Air Cool Planet and Comet, we don't think did a very good job of accounting for the fact that that UGA Swine Center has an anaerobic digester on it. All of the methane produced from the manure at this farm is burned in a digester. So if you don't account for that, which neither of those models appeared to adequately account for it, we would expect the emissions to be about twice as high as they were. And you can, when you look at it, you know, the two tools that did not really account for the fact that we were burning all the methane ended up having emissions that were quite a bit higher. And actually, one of the things we used some of the tools for is, for example, this one shows the Cool Farm tool. It did account for the digester, and you could see, you know, the manure management component was almost zero. There were some emissions associated with using the manure as a fertilizer and carbon stock changes from using the digested manure in crop production. But that tool did a good job of accounting for the fact that we did have a digester on the farm. The UGA dairy farm, it did not have a digester. It actually has a three-stage lagoon, anaerobic lagoon system. Here we had a little bit more variability, but I was actually somewhat surprised that at least 3 of the 4 tools appeared to give us very comparable total greenhouse gas emissions. Comet was much higher than the other 3 tools, and if we looked at the results on that, a lot of those emissions were so associated with the field production. I mean, Comet was a very good tool for looking at row crop production, I'd say less well suited for looking at the actual farm itself or animal farms. So this is using Cool Farm tool on the UGA dairy farm, and there you could see, you know, manure management was obviously the greatest source of carbon emissions on this dairy farm. According to this tool, you know, we were actually sequestering some carbon in the soil. According to Comet, we weren't. According to long-term soil testing, the soils there appeared to be fairly stable. So, you know, I don't think we are sequestering a lot of carbon, even though this tool predicted that we would be. Another interesting thing with this Farm Smart tool was it had a routine where it allows you to compare yourself to national averages, so you could see, is your farm producing more or less emissions than what the national average is, and it sort of made sense on this farm that, you know, a lot of our areas were maybe a little bit better than national averages, except for the manure greenhouse gas emissions. And because we have an anaerobic lagoon, because of our dry, hot and humid environment, we would expect the manure-related emissions to be higher than most other farms, and this model was showing that. So one of the things that we looked at, and the UGA farm was considering putting in a digester and wanted to know, what sort of impacts would we have. And using this Farm Smart tool, we could easily, once we got it up and running, show the dairy that, we'd be able to cut the emissions by 30 to 40% if we were able to cover those lagoons and harvest the methane. So some of the conclusions I had from this study, the tools produce varying results. Some of them, there are trade-offs. The campus carbon calculator, really easy to use, took hardly any time to run, didn't have to collect a lot of inputs, but you couldn't do much with the outputs either, and it wasn't really representative of the process. Other models like Comet was probably the most complex because they wanted so many inputs. And actually, one of the conclusions I drew from this study was it was highly unlikely that farmers would be able to use that because they wanted all the history of what were the planting dates and harvest dates for the past 20 years on all your fields, and then they wanted what implements were driving. Whereas some of the other tools were just like, okay, how many acres of corn production do you have, and using that. Now, if you're really interested in looking at changes in soil carbon levels, Comet's probably the best tool to use, but it's going to be difficult for most producers to be able to come up with all those inputs. And we were able to use these tools to look at, potential management changes and the impacts they would have on the farm. So, that was the real strength of maybe investing more time in a complex tool, is being able to make these changes. But you need to be aware when you select these tools that they have different strengths and weaknesses. The pork producer tool, for example, didn't ask hardly any questions about the land application areas, where Comet, really did that well. But they wanted the size of every single light bulb and every single motor in each of the buildings, whereas Comet didn't ask you hardly any questions at all about those type of things. So the tools are different, but surprisingly they came up with similar results. Another common use for these tools is product comparisons. I give several talks on climate change and agriculture to different groups, and I really hate this chart, even though I show it a lot because I have a small beef farm, and it shows that beef is probably one of the worst products when it comes to emissions. A lot of this is respirable carbon and the enteric fermentations associated with the animals. And I like to say that, I'm grass-fed on my farm, and we sell grass-fed beef, and so that's probably a little bit better. But actually, I looked at the data, and in general, I was somewhat surprised to see grass-fed beef actually has a higher carbon footprint. And I could find some studies that show different, but if you actually look at the animals, and it sort of made sense, when you're fed an all forage diet, you tend to have higher emissions. And actually, I found one paper that said, well, what happens to you when you eat a lot of broccoli or a lot of lettuce? And I said, oh yeah, I can see how that does affect the animals' emissions. So a lot of this, though, depends on how much is sequestered in the pasture. But I had another graduate student that they really wanted to look at this further, and we compared the carbon footprints on a confined dairy production system with a pasture-based system. These were roughly comparable size, of 500 head pasture-based dairy, 700 head confined dairy. The confined dairy was producing all their own feed, as was the pasture-based dairy, with just some minor supplementation of grain. and you can see the differences in the amount of feed and forage produced. I will say one thing I'd like to point out on this table is looking at the total pounds of milk per cow per year. The confined dairy was one of our better ones in the state and was producing almost twice as much milk per cow per year as the pasture-based dairy. So these are just some aerial shots of the farms. The pasture-based dairy had a center pivot system and rotated the cows around the center pivot system. It was a former cotton farm that had been converted about 4 years before this study, whereas the conventional farm was a very old farm, has been there at least 50 years and manages a lot of fields and to produce feed on the farm. What really surprised me was when we did these calculations and looked at the emissions. The confined dairy, if we looked at total emissions, was about 3 to 4 times higher than the pasture-based dairy. However, when we normalize that and look at that as a carbon footprint per pound of energy-corrected milk, they were almost identical initially. And the first time we ran it, we didn't include any carbon sequestration. When we added that component of it and used, it was actually a version of the Comet model to look at carbon sequestration in the soils, that reduced the pasture-based dairy carbon footprint quite a bit. And it was, since these were old cotton fields with almost no carbon in them, and we were going to a forage production system, the carbon levels were increasing. So we were seeing this carbon sequestration. And so the pasture-based dairy actually ended up being a little bit better than the confined dairy in terms of carbon footprint. But I share this with you not because you can take any generalizations home from looking at 2 farms, but this showed the utility of these tools and some of the things we're able to do. On each of these farms, we looked at several management changes and how those might impact these farms. So on the pasture-based dairy, for example, if we genetically increase production, i.e. had cows that were better suited, we could substantially reduce our carbon footprint. Decreasing the amount of poultry litter they're fertilizing with, raising more of their replacement heifers on the farm had very little impact. If they fed more corn, silage, and grain, they could reduce their carbon footprint, which was interesting because if you look at the far end on the confined dairy, if they used pastures a little bit more, they could reduce their carbon footprint. So, and then the confined dairy, probably the biggest thing was if they covered their manure storage and flared their biogas, they could reduce their carbon footprint. So in general, across the board, really just ways to mitigate. The first one, and the one that makes sense, and the reason that the U.S. production system is pretty efficient is just increasing the production per animal. And we've worked on this for years through reproduction and genetics, controlling disease, herd health. Anything we can do to increase our production per animal reduces greenhouse gas emissions. In feeding, the animal scientists are really doing a lot of work to look at different ways of processing feed, feeding ionophores, adding fats, decreasing the excretion through grazing or harvesting and grazing forages that are immature. All of these things, there's lots of things we can do to feed the animals better to reduce the greenhouse gas productions. Manure storage and handling is probably the biggest opportunity, though, and it was good to see that's the U.S. strategy. we can, by converting from anaerobic lagoons to some of these anaerobic digesters, or even by going to solid-based systems, like we use with poultry production, we can substantially reduce these emissions. Anything we can do to conserve energy on the farm, conserve fuel, that also reduces our carbon footprint and helps mitigate it. This can really save the farmer. So this is low-hanging fruit, because there's economic returns for reducing energy use or fuel consumption as well. And then finally, there are other ones, but increasing carbon sequestration is one that I think is really important. Almost all the livestock farms we work with have either pastures or croplands that they're also managing, and trying to increase the amount of carbon we're sequestering in the soil on these farms is really important. Dennis Hancock and some of the scientists here at UGA that have been working with some of these grazing dairies in Georgia have really been able to document pretty dramatic levels of soil organic matter increase in pretty quick times. You can see this is 3 different paddocks on a grazing dairy in Risse, Georgia, and shows just how much carbon they were able to keep in the soil as they converted these farms from conventional to more rotational graze type dairies. This was equivalent to up to 7 megagrams of carbon per hectare per year in the upper 30 centimeters. If that carbon's in the soil, it's not going up to the atmosphere and it's not an emission. So we think that looking at some of these grazing systems may have a lot of potential as well. I think I'm about at my time, so I'm going to thank you for your attention, and we'll be happy to take any questions now.